we want to find the partial derivatives of the following two functions, both with respect to x and with respect to y. So let's look at the function a, part a. We have x to the fifth times y squared minus 3x times the square root of y plus y times the natural log of x plus 3y. So if we want the derivative with respect to x, then we think of y as being a constant. So that means that y squared is a constant, and y squared then is the coefficient of x to the fifth. And using the constant multiple rule, the derivative would be y squared times the derivative of x to the fifth. And from the power rule, that's 5x to the fourth. Then we have a minus. The square root of y will be treated as a constant, and of course 3 is treated as a constant. So we have 3 times the square root of y, and then times the derivative of x, which is 1. And then we have y is a constant, and the derivative of log x is 1 over x. So we have y times 1 over x. And as far as x is concerned, 3y is a constant, and the derivative of a constant is 0. So our derivative with respect to x for the first function is 5x to the fourth y squared minus 3 times the square root of y plus y over x. Okay, now let's take that same function and find the derivative with respect to y. So x to the fifth is a constant, and then the derivative of y squared is 2y. So derivative with respect to y, x is treated as a constant. So here 3x is a constant, so we have minus 3x times the derivative of the square root of y. The square root of y is the same as y to the 1/2, and so the derivative of that is 1/2 y to the minus 1/2 from the power rule, and that is 1 over 2 times the square root of y. And then y times log x. Log x is a constant, so we get natural log of x times the derivative of y, which is 1, and then plus the derivative of 3y with respect to y is 3. So the derivative with respect to y of that same function is 2x to the fifth y minus 3x over 2 times the square root of y plus the natural log of x plus 3. Okay, part B, our function is 2y over x plus y squared times tangent of x plus 4 times the secant of y. So the derivative with respect to x, we have 2y. Let's write down the derivative with respect to x. And we have 2y times the derivative of 1 over x, which is the same as x to the negative 1. And we want the derivative using the power rule. That's negative 1 times x to the negative 2, which is negative 1 over x squared. So we get here negative 2y over x squared. And then derivative with respect to x, y squared is a constant, and the derivative of tangent x is secant squared x. And then 4 secant y is a constant as far as x is concerned, and so the derivative is 0 with respect to x. So negative 2y over x squared plus y squared times secant squared x is our final answer. And let's take the partial derivative now with respect to y. So 2 over x is a constant, and the derivative of y to the first power is just 1. Then in the second term, tangent of x is a constant, and the derivative of y squared is 2y. And in the last term, 4 is a constant, and the derivative of secant y is secant y times tangent of y. And so the final answer is 2 over x plus 2y times the tangent of x, and then plus 4 times the secant of y times the tangent of y. So those are our partial derivatives.